We know how to calculate derivatives. We've studied derivatives already, and now we're doing the application of derivatives. So the first one that we studied was velocity, which was taking the first derivative of a function. And remember that velocity is the distance that a particle travels. Okay, so it's different than speed because speed is the absolute value of velocity because speed has to be positive. Now acceleration is the change in velocity over time. So typical unit is meters per second squared, and it's found by taking the second derivative. So the derivative of velocity. So you're going to be given an equation by finding the first derivative, that's velocity, and the derivative of velocity is acceleration. So we've taken the derivative of the position function twice. So here's a graph, and it states where is the section of the graph, where does it have negative acceleration? Okay, so if you take a look at this graph, it has negative acceleration when it's concave down from B to D. So you're given a position function, s of t equals 5t cubed minus 3t squared plus t minus 6. And you're asked to find the acceleration of the object after t seconds. Well, if you're asked to find acceleration, then you're looking for the second derivative. The first derivative is velocity, so s prime is 15t squared minus 6t plus 1, and taking the second derivative, which is acceleration, the equation equals 30t minus 6. When is the acceleration 0? You have to make the second derivative that you've taken equal to 0 and then solve for the variable. So in our equation, we had 30t minus 6. So we make that equal to 0. Solve for t using our algebra skills, and t equals 1/5 or 0.2 seconds. When is acceleration negative? Well, in order to find out when it's negative, you're going to make a wriggle graph and check numbers on both sides of what you solved for t when acceleration was 0. So we found that acceleration was 0 at 1/5 seconds. So we plot that on a wriggle graph. And I'm going to plug in values 0 and 1 into the second derivative because the second derivative is acceleration. So notice when I plug in the value 0 into the second derivative, it equals -6, so that's where it's negative. It's negative where t is less than 0.2 because 0.2 equaled my fraction of 1/5 that I had earlier.